Okay, the first example I'm going to do about arithmetic sequences is 4, 10, 16, 22, 28. And here you have to show that it's arithmetic. First of all, you need to show it is arithmetic sequence. And for arithmetic sequence, to show that, we need to have a fixed difference, which is called common difference. So 4, 10, 16, 22, and 28. So if you find the difference, which is also called first order difference or first difference, so this is plus 6, plus 6, plus 6, and plus 6, which means D is plus 6. We have a fixed or common difference. So this is called common difference. So that means it's an arithmetic sequence. I'm going to use AP, which is the arithmetic progression. So we showed that it is an arithmetic sequence or arithmetic progression. Now the next one is you have to find the general term. So to find the general term, that's what I was trying to explain in the lesson as well. So in u1 is equal to 4, u1 is the first term, and u2 is equal to 10, which is your second term. So we can write 4 as 4, and we can see how can we do it further. But 10 is equal to, we always need to use the pattern here, which is 6, which is the common difference. So I'm going to rewrite this as 4 plus 6. Then the next one is 16, which is 4 plus 6 plus 6, which can also be written as 4 plus 6 times 2. And then you have 22, which is 4 plus 6 times 3. And then this one is 4 plus 6 times 1. And this becomes 4 plus 6 times 0. So I'm going to rewrite this again. So my 4 is 4 plus 6 times 0. 10 is equal to 4 plus 6 times 1. And then 16 is 4 plus 6 times 2. And then 22 is 4 plus 6 times 3. So this is u1, this is u2, u3, u4. So now what we need to do is to find un will be equal to, because there is no change in this 4. So 4 stays same. And now here, which is the common difference, is again no change here, so that will be 6. And then here, if you have first term, you have 0 here. If you have second term, you have 1 here. If you have third term, you have 2 here. If you have 4, you have 3, which is 1 less than the term number. These are called terms. So this is 1 less than, which means here if you have un, so we should have n minus 1. So I'm going to simplify this, and we got 6n minus 2. So that is your general term. We can check it. So we can check this. So if I substitute, let's say if I want to find, because I want to check, so I want to check with the terms which is given. So let's say u5. So then this becomes 6 times 5 minus 2, 30 minus 2, which is 28. So we should get u5 as 28. Let's see. So this is u1, u2, u3, u4, and u5. So our u5 is 28, which means it is correct. So the first part was show that it's an arithmetic progression. By that we mean we need to do is we need to find there should be a common difference, which in this case was plus 6. And then this is your general term. So if I want to generalize it, instead of using, in this case it is 6n minus 2, but if I just want a general term, so what is this 4? 4 is your u1. So in general, un is equal to u1 plus, and here you already observe that it is n minus 1, and then 6 was your common difference. So this actually is the general term for arithmetic sequences, and this is called general term or nth term, or this is also called general, nth, or last term. So there are 3 names for this un. Okay, so make sure that you know all of these 3. Okay, now the next part for this one is, so now what you need to do is, the next is you need to find the 55th term. So you need to find u55 here. Now to do that, I'm going to copy down un again, which in our case was, un we got was 6n minus 2. So for 55th term, you need to substitute, replace n by 55, and then you will find 6 into 55 minus 2. So you can do this, you can calculate this value. So 6 times 50 is 300, and then 5 times 6 is 30, so 330 minus 2, so 328. You can also use a calculator. You can also use calculator to do that. So to use the calculator, what you need to do is you need to substitute here. I'm not going to right now worry about because here for general term I'm using un, and here you can see this is x, so I'm not going to worry at this point that it should be n, so I'm going to keep it as x. So if you remember, our general term was 6n minus 2. So what we are going to do here is, instead of n, I'm going to do 6x minus 2. So I'm going to clear this, and then you are going to enter your values here. So this is 6, and then x, and x is here, minus 2. Okay, then after that what you need to do is you need to go to second, and if you go to window, you can start your table at, because we are starting with first term, so I can start at 1, and then you go to second again, and then you go to graph, and then you can see your terms. Now we want to find the 55th term. I'm not going to scroll this all the way down to 55. So what I can do here is I can go to second, table set again, and I can put there 55, and then I can go to second table, and I can see my 55th term is 328, okay, which we also found 328. Now the next question they asked you is 584 a term of the sequence? So you need to find out, is 584 a term of this sequence? Okay, so and what about 382? So you need to find out whether they are the term of the sequence or not. Now what does that mean? So term of a sequence, this is the term. So un is the term of a sequence. So what you need to do here is you need to substitute un as 584. So if you do 584, and then you have 6n minus 2, so 584 plus 2 is equal to 6n, and then 586 over 6. If you get n as a whole number, which means it is one of the terms in the sequence. If you do not get a whole number, which means it's not the term. So here when you divide this, you get 97.666, which means 584 is not a term of a sequence. And the next one is 382. So you do exactly the same thing. Now un is 382, and then you do 382 is equal to 6n minus 2. 382 plus 2 divided by 6 is equal to n. And if you get a whole number here, so 384 divided by 6 gives you 64. So 382 is a term of the sequence, and which one is it? It's the 64th term. So this is how you will find out this one. Okay, now I'm going to do the example number 2. So in example number 2, if you have 3k plus 1 and 2k and 3, they are consecutive terms of an arithmetic sequence, find the value of k. So you have to find the value of k here. So now in this question, so what do you mean by consecutive terms? So for example, 2, 4, 6. So they are the consecutive terms of an arithmetic sequence or progression. Now if these three are the three consecutive terms of an arithmetic progression, we have to find k here. So 3k plus 1 and 2k and 3. So I'm going to just rewrite it. So this is 2k and this is 3. So this is, let's say this is u1, this is u2, and this is u3. Now we know that if it's an arithmetic progression, then we should have a common difference. Now how do we find common differences? So if you remember, for 2, 4, 6, to find d, what will you do? 4 minus 2 and 6 minus 4. So what we are doing is to find d, u2 minus u1 or u3 minus u2. So we are always subtracting the u2 minus u1, so the previous term from the next term. So for this one, to find d, so my d will be 2k minus, I'm going to use bracket. So what I did here is u2 minus u1, and then this is d, and also d is equal to 3 minus 2k. But both of them are d, which means both of them should be same. So 2k plus 1 must be equal to 3 minus 2k. Now I'm going to open the brackets. When you have negative outside, the sign will change. So this is minus 1, 3 minus 2k. Now I'm going to collect everything, or before collecting, I will simplify. This is minus k, minus 1, 3 minus 2k. So minus k plus 2k is equal to 3 plus 1. So you get k is equal to 4. And now they didn't ask you what are those terms, but we can go and check it. So if I substitute k is 4 here, so 3 times 4, which is 12 plus 1, 13. 2 times 4 is 8, and then 3. And then you can see the common difference in this case is negative 5 here. And now we are going to do the last example of this lesson. So last example is example number 3. You have if u2 is equal to 8 and u7 is equal to negative 7, and you have to find un. Okay, so two terms are given and you have to find un. So to find un, the first step you should do is write down the general term. So this is u1 plus n minus 1 into d. So that is your general term or last term or nth term. So we have this general term. Now if you look at this, we need to find out, to find un, we need, because in un you will have n. It's a general term, so n will be in the final answer. So what are the things which you need to find out here? So you need to find out what is u1 and what is d. So there are two unknowns which you need to find. That's why there are two conditions given here. So let's see u2, u7. Now the another thing which is very, very important, which you need to remember is that if you have 2, 4, 6, and the 4 is, this is equal to, because d is 2, so the fourth term, and this is u1, this is u2, this is u3. So u2 is simply u1 plus d. So it's one difference, common difference away from first term. 6 is two times your common difference away from the first term. So u3 is u1 plus 2d. And then u4 is u1 plus 3d. So this is something, obviously you can use this formula also to find out. If I have to do u2, I can substitute n is equal to 2. It will give me u1 plus d. But you should also know this like by heart, that whenever you have u2, u2 is one distance away from u1. u3 is 2 distance away from u1. u4 is 3 distance away from u1. 3 distance, and that distance is your common difference. So now here, if you have u2 is 8, which is same as u1 plus d, which is 8, and then u7, this is equal to u1 plus 6d. Again, you can substitute in the formula, or you can use that u1 is 6 common differences away from u7. So that's negative 7. Now we have to simplify this. This is called simultaneous equations. And this one is very, very easy to simplify, because u1 and u1, we have same coefficients, so we just need to subtract them. So when we subtract them, this will get cancelled. D minus 6d will become negative 5d, and this becomes 15. So d is equal to negative 3. So once you have d is equal to negative 3, we'll substitute in one of the equations, and obviously it's easier to substitute in the first one. So u1 minus 3 is equal to 8. So u1 is equal to 11. So that is your u1, which means my un, now this is the final answer which we need to give, un, which was u1 plus n minus 1 into d. So this is 11 plus n minus 1 into negative 3. And now we need to simplify it. And then you get here 8 minus 3n, or negative 3n plus 8. So that is your final answer. So so this is the example number 3. And I hope that all 3 examples are clear.